Good day. I am Christopher Allen Abbott, ID 124, and I'll be teaching CALENG1 long quiz number 1. And for this specific tutorial, I will be teaching the quotient rule. Now, I won't be using any lengthy processes and will instead opt for shortcuts or uh, faster techniques such as the general power rule. Now, let's start with our definition. Now, this is the equation for the quotient rule. Given a function u and a function v, the derivative of u over v is u prime v minus v prime u all over v squared, where v is not equal to 0. Now, it's a bit lengthy to memorize, so this is the phrase I use. I, meaning the function at the numerator, d, meaning its derivative, and low, meaning the function at the bottom. So high d low minus low d high all over low or low squared. It sounds a bit silly, but it does work. And now with that out of the way, let's start with our first problem. So we are given f of x equals 6x squared all over 2 minus x. First, we find our u and our v. So we let u is equals to 6x squared and v equal to 2 minus x. Next, we find the derivatives of these functions. So u prime and v prime. Derivative of 6x squared and the derivative of 2 minus x. Let's start with u prime. Now for this one, we simply use the general power formula, which would be 2 times 6 x raised to 2 minus 1. So we took the original exponent of our x, multiplied it with the whole thing, and subtracted our exponent by 1. So that gives us 12x. As for this one, you can evaluate each term separately to find its derivative. So the derivative of 2 is simply 0. The derivative of any constant is 0. The derivative of x is 1. So this gives us 0 minus 1 or negative 1. So now we have u, v, and u prime and v prime. We can then go on with our quotient rule, which is uv, u prime v minus v prime u all over v squared. So let's write that out. U prime, it's 12x. V, it's 2 minus x. Minus v prime, which is negative 1. And u, which is 6x squared. All over v squared, or 2 minus x squared. Now let's simplify. 12x raised to this, multiplied by this, sorry. That gives us 24x minus 12x squared. This just cancels out to become addition. So that's plus 6x squared. And then we evaluate our denominator. That's 4 minus 4x plus x squared. We just distribute this by itself. Now we combine like terms. Here we have, I'm sorry, this is minus 12x squared. So here we have negative 12x squared and plus 6x squared. So we can combine that to get 24x minus 6x squared all over the denominator, or 4 minus 4x plus x squared. And so this is the the derivative of our original function. We didn't really need to simplify the denominator, but it worked out in the end. Let's go to our next question. So this is our next problem. It has the same form as the previous one. So let's just start. We'll let u be 3w plus w raised to 4 and v 2w squared plus 1. Now we find u prime and v prime. So that's the derivative of u, which is 3w plus w raised to 4, and the derivative of 2w squared plus 1, or v. Now, again, we can just distribute these and evaluate each term independently, but I'll just go straight ahead with it. So the derivative of 3w is just 3. Derivative of w raised to 4, that's 4 times w raised to 4 minus 1, as per the general power formula. That's 3 plus 4w cubed. The derivative of 3w is just 3, since w is equivalent to w raised to 1. And we subtract minus 1, we subtract 1 from the exponent, that becomes w raised to 0, which is just 1. So it becomes 3 times 1, which is 3. Now let's start with v, 2w squared plus 1. Again, general power formula. And the derivative of any constant is 0. And this simplifies out to 4w. And now we have our u, our v, our u prime, and our v prime. And then we can go ahead with our quotient rule. So I won't be typing it out anymore. I'll just go straight ahead with the calculation. First, we have u prime, 3 plus 4w cubed, multiplied with our v, 2w squared plus 1, minus our v prime, 4w, multiplied with our u, which is 3w plus w raised to 4. And we divide this whole thing with v squared, or 2w squared plus 1 squared. Let's start simplifying this. 3, this whole thing multiplied by this whole thing, we just distribute it. That's 6w squared plus 3 plus 8w cubed, raised to 5, sorry, minus 12w squared minus 4w cubed. Then our denominator, we just distribute it with itself. That's 4w raised to 4 plus 4w raised to 2 plus 1. And then we can simplify this further by combining like terms. So first we have 6w squared and negative 12w squared. We combine that, that's negative 6w squared. And then we have 8w raised to 5 and minus 4w raised to 5, which is 4w raised to 5, and then plus 3. The denominator is as is. There's nothing left there to simplify. And this is our answer for the whole thing. This, yes. We also didn't really need to simplify our denominator in the end, but it worked out. So now let's start with our third problem. So now we're on our third problem. It's pretty much the same form, but we've introduced a squared of x. So let's start. Let's define our u as the numerator, so square root of x plus 2x. Our v, the denominator, 7x minus 4x squared. Let's find u prime and v prime. Now, square root of x is simply equals to x raised to 1/2. So we can use the general power formula. So that's 1/2 times x raised to 1/2 minus 1. And plus 2x becomes plus 2. This simplifies to 1 over 2 square root of x plus 2. For v prime, 7x becomes 7, and then you can use the general power formula for negative 4x squared. So 2, 4x raised to 2 minus 1. This simplifies to 7 minus 8x. So now we have our u, our v, our u prime, and our v prime. We can go ahead with the quotient rule. So let's start with our u prime. That's 1 over 2 square root of x plus 2 multiplied with our v, 7x minus 4x. And then we start with our v prime, 7 minus 8x. And then our u, square root of x plus 2x. Sorry. And we divide this whole thing with v squared, which is 7x minus 4x squared, quantity squared. Oh, almost forgot. Here, 7x minus 4x squared. Okay, so let's start simplifying this. Let's take a look at this specific term as it has square root of x. First, we distribute it with these. So we have 7 over 2 x over square root of x. We can simplify this using our uh, exponent rules. So this is simply x on this 7 over 2 times x raised to 1 minus 1/2, which is equal to 7 over 2 x raised to 1/2, and it's just 7 over 2 square root of x. And we can write that down. This is, first term is 7 over 2 square root of x. And then we do the same thing for the second term. That's 4 over 2 minus 4 over 2. That's x squared over square root of x. That's x raised to 2 minus 1/2. That's equal to 3 over 2. That's x raised to square root of x. And let's proceed with the rest. So that's 14x minus 8x squared, and it becomes minus 7 square root of x. Sorry, let's remove that. And minus 14x. This becomes minus positive, 8x squared of x plus 16x squared. All over our denominator, which is this. This simplifies to become 49x squared minus 56x cubed plus 16x raised to 4. Now we can simplify this further by combining like terms. So first we have 7 over 2 square root of x, and we have minus 7 square root of x. 7 is simply equal to 14 over 2, so 7 over 2 minus 14 over 2. That's negative 7 over 2. So negative 7 over 2 square root of x. Next we have this. 4 over 2 is simply 2. So we have negative 2x squared of x plus 8x squared of x. That simplifies to plus 6x raised to x. Sorry. 14x is cancelled out by our negative 14x. And negative 8x squared plus 16x squared is simply positive 8x squared. And now we have our denominator, 49x squared minus 56x cubed plus 16x raised to 4. And this is our final answer. You can rearrange this in according to descending terms, but it doesn't really matter. And as you can see, we didn't really need to simplify our denominator, but it worked out in the end. Thank you so much for watching. You may also avail syntax tutorials by scanning the QR code flashed on your screens. Once again, this is Christopher Allen Abbott from Syntax, paving your way to excellence.